let's move to the second subchapter on the chapter 4, algebra and symbolic math, working with expression. So I prepared some the quick summary in the mind map. We got this open question from last subchapter is how we can let the SymPy to help us do this expansion for some those expressions don't elect as the most basic one. So like this one. So that is the first part we will learn from here. So that is we call this factorizing. That is the factorize. So for such kind of things, so we will make that into this the expression. In the vice versa is the expand. So we will put this expand to something is help us to do the calculate. So we do the expand and the factorize in this first part. Then we will look at how we can make some nice printing result with this pretty printing the function. That is, we will import another part of print. That first is the we import another factor and expand. And then this once we have an expression, we want to do the substituting in value. That we will have this simplify the function or the class will be import, and we can use this subs function to put value and then use this simplify to calculate those value. And we will calculate the value of our series as a sample. Last but not least is we will learn is how to convert string to mathematical expression. So that string means is we will read from users' keyboard inputs. Then we will make that looks convert like our SymPy the workable expression. So we will import another library, the class called is simplify. Don't mix with this simplify with this simplify. So that is a different purpose. And we will also learn is some try except using this simplify arrow handling. Because whenever you, that is our good hobby. So whenever you are dealing with the user inputs, try to consider user can input something is irrelevant or something is not valid or not allowed. So you need to control if that happened. It's not make your the program crash, or you need to make that catch and handle in certain expected way. Then we will finish this chapter as an expression multiplier. So that is the basic thing. So let's do this the step by step. So working with expression. So let's continue with our last part. Is we have our the symbol defined like this. X is defined as X, Y is defined as Y. So we have this symbol one by one. So we have expression, this one. So first is we make our expression is X is square with 2 minus Y squares 2. So if we make it express, it's not changed. But if we want to see, that is in mathematical the class we know is can be do the factoring like this. So if you want to show that is we will starting to import this called the factor class. Then once you have that is you can do the factor expression your variable, and the SymPy can help you to do the calculation. And if you have this the let's see, so express is the x minus 1 and then the x plus y. So now when you do this express, it's not help you to do this the calculation. So for this is we need a vice versa different direction. The class code is expand, which we mentioned during the last video. Now is if we do the expand express, then you can see it will calculate for you. So x times x, xy, and minus xy, and y times y. So it's with the negative symbol. So now it's x square 2 minus y square 2. So that is back to the what the factorizing's origin. So you can treat this expand and factor are just two the operation just used with the vice versa direction. So once we have this expand and factor, we can store the factorized expression in a new label factors. Then we can do the expand and we can evaluate this. So let's see try this one. So this now is a square 3 plus is 3 times x square 2 times y. So we should remember this in your mathematical task class. So x and then times y square 2 and plus is y square 3. So let's see express. It helps us do some a little the shorter, but they it doesn't calculate that because it's not like this most simple or most basic expression. So what we will do is we already load the factor. So we put this factors equal to factor this express. So now let's see the factors is make the call. This factorizing is with the x plus y, and together is squares 3. So that is the calculation. And let's see the expand this, the expand factors. Then you get back to this expression. So they are just the enable. The factor function is able to factorize expression, and then expand the function, expand the factorized expression to return to the original the expression. So please remember factor and the expand function altogether. But also be aware is you need to import from the different class. So if you try to factorize an expression for which there is no possible factorizing, the original expression is returned. So we will use this one. So you cannot do like this express is x plus y plus x times y. That is kind of already most simplified form. So if you want to do the factor express, so factor. So it just gave you the way making that is rewritten, but the form, the result is still same as the origin because there's no way to have a further factorizing. So similarly, is if you pass an expression to expand, but it cannot expand further. So for example, is our expression is here. So this cannot be expanded as well. So let's see. So express. So you still get this similar or the same the expression back. And then is next. Let's talking about the second one is the printing. So that is interest the improvements from this SymPy from the mathematical view. But actually, I should say is if you work on in the terminal, it's not 100% pretty. So, but it's already the make a difference to like x times x plus 2 times x 2 times y plus y times y. So now we have this x squared 2, y squared 2. So if we do this pretty, so let's load this import p print. Then we do the p print express. You can compare this with this. It's actually using the 2 lines height. But this square is actually go to this upper right corner. Is make and there's no this asterisk the animal. It just use our middle dot. That is kind of like the similar way when you write down in your paper. So that is called is a pretty print. It's a print like this way. So, but it's not like such kind of the pretty. To me, is this small tool is a little far away to this X. But that is the different way to do that. And if we have another one, sample is 1 plus 2 times x plus 2 times x with the square 2. So if we don't have a pretty print, it's just a 2 with our asterisk and then x with 2 asterisks. But if we do pretty print express, then here is a 2 with a dot x squared 2, 2 with a dot x plus 1. So that you just need to can compare. So these are using 2 lines. So here is the line 1, here is the line 2, but they just treat it as the this printing format. It's not changed the value. So express is still the same. The form, just when you try to display in the terminal, is getting some little nicer this printing result. And also we now you can see is the days coming from the ordered by the powers of x. So the higher power is the display the first. Well, if you just want to show this, I want to show the 1 first, 2 times x second, and this higher powered of x is in the last. There's a specific class you can import called this initial printing, but this is not only used for this single purpose. It have more other this purpose. So, but we can use this simply import int printing, and once we have this, we can use the feature from this initial printing. Our order arguments is the code is reward legs. Once we set that, then this when we pretty print this expr is start from the lowest the powers of x and aex okay pr. You can see here is always have this printing. So let's see. So if I put this expr equal to x times 2 plus 2 times x times y plus y times 3. So now let's see. So expr now is getting x with the lowest, but then this they treat is y as the without our x, so it's x is the powered with the 0. So then y times the powers 3 is showed earlier. And you can see once you have this initial printing, this activated, you don't need the pprint. So it's always using this pretty print show this one. So that is the initial or IIT printing the features. And then let's go to the printing series sample. So this one is let's quit from the Python, and we can make our the code. So here is a printing series in chapter 6 is our 04021 is the printing series.py. So we can now see the purpose, printing the series, but we will not write that. That is author. Here's my another name is the date. So let's import the necessary the classes. So we have this SymPy. We still have that explicitly. So, but if you want to import everything is fine. But we try to select based import. So we need the symbol, the single symbol, and the pretty print, and IIT printing. So that is enough for us to use. And then this we have our main code. And this code is we input our n. So this n is the the variable, x is the symbol. So n is input. So we will convert this to int here. So input, enter the number of terms you want in series. And then this we will define our print series function. So we will transfer the n. So then from that is let's def of print series with the n drop in here. And then this first we initial that because it's x is powers of x is from the lower to higher. So that is the way so we need initial print in order, right? Reverse legs. But from our earlier test is once we have this, looks like is we don't need this a pretty print. So it's already have that function activated. But let's have the test. So first is we define symbol. So you remember is actually you don't need to make that assign also to x. You can assign this to anyone, any kind of those variable. Just is our symbol is x. That is the key. So series is equal to x. And then the series is first. Then here I think is the author. This 4 should be the no indent. So series is equal to x first. Then we will have I in range 2 to n plus 1. So n plus 1 means is the last index boundary is n. So we want this looping till n. So and x we already have, and we gradually adding those the number 2, number 3. So we're starting from 2. And then here we have this indent. So series is equal to series plus. So x now is as a symbol, so we can use x, and the variable is the I. So x powers I divided by I as well. So that is our formula, and we keep adding those. So series is a series is go to this one. So now we have done this, and we will return series. So let's see. So if I use just the series, let me run. So if I just put 3, oh no, so I need to print. So but I think it's no pretty print is also should be fine. Oh no, so pretty. So that is the testing is still not like this way. So pretty p print. So now let's run, and I get 3. So now it's good. It's x plus 2 x times the powers 2. So it's like if I go to this, if we don't have our pretty print, it's print like this way. So but now I have the pretty print, so I can run this for some larger one. So let's say 10. You can see now it looks nice. So I can run this series for whatever, and then this I can print this. Let's make our biggest 100. So you can see it's making several lines, but they just put those nice print. So that is the first the sample code we will put in here. So let's clear the screen. And then this, let's try to see the substituting the value. So we have our expression, and how we can calculate the value of the expression for certain values. So we need to transfer or send some values into the expression, then we expect to get the result. So let's back to our Python. So we should from this SymPy import symbol. So we get this, and x we can assign. Oh, so we also need to, let's use the symbols. So x, y equal to symbols. So we learned this is x, y. So now x name or y. So we have this. Now let's see is x times x plus x times y plus x times y plus y times y. So I got this simpler y's, this expression. So this can be done without this expand or the factoring. So, but if I want to evaluate this expression, how I can do that is I can do this substitute the numbers in the symbol using these subs. Actually, it's a short of the substitute. But if you want to use this, you just directly go to this function. So let's see. So I gave a name for this. Then express dot sub, and we transfer x with value 1. This as a dictionary, and y is with value 2, with this curly braces, and then this with this parentheses. Then you can see it's sub is has no attribute. Oh, it's subs. So I got 9. So I can put this result assigned. Then this now result is 9. So if I put this, I put x is 3. Now let's see the result is 25. So now it's through this dictionary-based way you can transfer the values to them, and you can also transfer the just is x. So x I transfer is 1 minus y. So that means is I will use 1 minus y to replace x. Then I will just remove clear x, replace x by certain y expression. That is normally is if you have the group of the functions or the equations you want to the clear one of these unknown the symbol, though you use this way. So use one symbol to replace another one. So that is the way. So you only put the subs with one this dictionary pair. So x is 1 minus y. So that means y is keep still. So now is I got this originally is x has this one. Now is x will be y 1 minus y and the square 2, and here is 2 times 1 minus y times y, and this is keep, and then this the SymPy gave a certain this simplification for this this way. So let's see. So we still say we have this substitution, and here is introduce a little bit things for you about this dictionary usage. And then this once we have this expression, then this we can have from the SymPy import this simplify, and we can simplify this way to see is how this can be further the simplify, because here you can see is 1 minus y is just replaced, but they didn't do the further calculation. So let's do this for the simplify is pi import simplify and simplify this this one. So let me put that. Then I got 1. So that is the way so you can have another the class to help you. So and let's do our calculation. So we have print this one. Now we transfer the sum, the initial value or the expected value. Let's see what's the result for this one. So we will have our the starting from this one. So let's do this. Calculate value of. So we have this one. Let's see the calculate. And then, well, let's see what we can still have is we have those are enough, and for these subs, the function or the method is function is already built in within the SymPy when you load these those classes, so we can have that, and we still have this print series. So and but when we do this print series, is we will try to make that transfer the value. So should be 2 arguments. Another is x value that I want to transfer that here. So make this x value, and we need to let user give us x value. So this x value is just our float, and the input enter the value of x for evaluating. So then we transfer that, and we don't need to do this change. So all these are still same. Now you can see the author makes some correction on this one. So 4 is here. So that's good. Then we are just adding the series value. It's equal to, we have the series already, series subs with the x replaced by the x value, and then print this. We don't need the pretty print, so value of the series at 0 is the x value, is 1. Let's see, so make that dot to f, and also this dot to f, so that is not long too much. Format x value and series value. Okay, so let me see why here series value. Yeah, it's no typo error. So let's quit from the Python, then clear this. Let me save and run. So let me put this 5, and let's see what's the value I want to test. So if I want to test this maybe 1.5. So I got this one, and then I got 1.5 with x, and the value is this one. So that is the easier things using the subs. You can send the arguments and then get these expressions result. We move to the last part, is the converting string to mathematical expression. So we will introduce this simplify. So let's put this. Simplify is kind of, let's go to the Python. So if we need to do is simply import. It's not a simplify. So let me emphasize again. So it's a simplify. And then what's this is the use is to have the expression. So enter our expression. Let's see, like this. Then here is enter this one. Let's enter x times 2 plus 3 times x plus x times 4, maybe 2 times x. So I got this, then I see the expression. So I got that. If I just put the expression, you can see the single dots before and after. That is our string. So you cannot use the like is the expression dot subs like cx with y is maybe 5. I will get an error because I cannot use a substitution tilting the one value of 5 to a string. So what we need to do is we should to do this expression make her simplify the expression. So let's make that expression 1. So express is here, expression 1. Now you can see without this single cause, and also is already simplified. So now is let me put this one. I apply that to expression 1. X is not defined, so X is our symbol. So let me also from simply import symbol x is equal to symbol x. Now let me see whether I can do that afterwards. Oh, perfect. Is I can define x, then put x as a symbol. Then this expression can be used these subs with a number. So and then this we can say 2 times express 1 is we can have those one. So that is the simplify that we can use, and we will let's see. So from those the last one tell us the simplify isn't able to convert the supplied input expression. So which means if we input one expression and we simply do this simplify between 2 and x is because it's this one. This one should be 2 times x with this star in the middle, but it's in the invalid typing by user. So that way is we need to ensure it so we can get some the cat try and express. So now let's make this a new program to document this. That is the print series. Let's see that still the number 2, so 3. Simplify arrow handling.py. So purpose demo how to catch arrow in simplify. So from simpy we import simplify. And what we also need to do is we need to make our simplify arrow loaded. That is not in the simpy directly. It's in the simpy call dot simplify import. It's a capital S simplify arrow. Now we have that is we can see express equal to input. So simplify can help us do, let's quit this first, can help us do this converting from the string to our valid expression, but the prerequisite is they are valid. So if not valid, let's do this way. So enter our, let's say, magical expression. And then we will use try with the express. We try this p5 express. And if not express, so we need to, let's see, so express whether we need to print that. No, I think it's otherwise it's except simplify arrow print invalid inputs else print express. So this simplify arrow, let's see, simplify arrow, let me see why it's not correct. That's right. So let's see, cannot import a simplify arrow from simple call simplify. So maybe these are already in the different library now. Simple arrow. This is already in the SimPy, so let me see. So, SimPy code. Ah, so my bad is that's a typo error. So here is SY. Now it should be okay. So let's type some invalid things like this one. So x, just to make simple, 2x. So invalid input. But if I put this valid input, so x times 2 plus 2 times x. So now I get this. Why did this coming from here? Let's see. So no. So let's also comment this. So if I don't have that else, you will see here it's nothing. So you need to do this else to see is, if there's no exception, then run this. So, but if you in the command, it will give you this. We only try this invalid situation, but if you want this still putting the correct information outputs, then we will make that. And the last part is let's try this another code is called the expression multiply. So that is similar like this way. So like x plus y times y minus x, something like that is if we want to do the multiply, and we will see. So what's that result? So that is what we want to see here. So purpose is the product of two expressions. Yeah. Let's first we should have when we have two expression, want to do the time, so we need to expand that. So we need from SimPy import the expand, and since we will read from the keyboard, so we need simplify as ym. So I have these arrows earlier. So oh, not this. Simplify. This one. And also we need this arrow handling. So simpy.code.simplify import capital S simplify arrow. So we have our name equal to min. Then is we will read two expressions. So expression 1 is equal to import. Enter the first expression. And then copy this and put this second. And here is the number 2. And we will try. So try is the express 1 is equal to simplify 1. 2 is simplify 2. And then what the product is in this else. So we just try this to simplify. If that's not okay, we will see. So anyone is not okay is simplify arrow, then print invalid input. And then else we will do is the product express 1, express 2. So we have 2 arguments. Then we should have that. Then let's make our product function. So with 2 arguments. And the product equal to expand product times product 2. And we print product. Then that's fine. So let's run this. Oh, so this here is through the logical check. And then first one, let's see what's the sample x times the square 2 plus x times 2 plus x. That is 1. Second is the x times squares 3. X times 3 in the plus x, and now you can see it's calculated this one. So and we you can put this those and if I make another one is x times 3 plus 2x. So and no matter is this 2 plus 2 times x plus 1, then I will get invalid input. For first one is not valid. So that is the so far I think is we finished the second part. Let's have a quick recap. Is we did starting from the factorizing and expand. So these two they are the vice versa direction. Then we learned the pretty print. And then this using this subs to do this replace the value and to do the validation of these expressions calculation. And we did our function the defined and make a program to calculate the value of the series. And that last is we convert the string to the expression using this simplify. Also, we have here is simplify, so you need to distinguish these two. And we also make our error handling and may use this simplify and error handling to do this expression multiplier, the two. So I hope is you learn this a lot from this almost 50 minutes video, but working with expression is quite important. Try to review this before you go to the next video. Next section is we will use what we learned in the expression to talk about how actually is we can solve the equation. So the different type of the equation. So let's go to that quickly. So see you in that video. Bye for now.